On the homework questions, problems you want to see worked off it.
I have 28.
28.
I actually didn't get 24 to 32. I did not understand those. I didn't get 28 to 32. I'm gonna get 28.
I don't get these questions.
So make sure you ask. 28. Same thing as on the quiz. Says find the value of the variable and st, so the length of st, if s is between r and t. So we're going to draw a segment, put some points on it. What did it say this time? S is between R and T, so what's this point right here have to be? S. What's this point have to be? How about this one? Good? I'm not going to have school guys up this
I told her to fix her strings.
Quit worrying about her string and worry up here.
You were dropping them.
So that's part of the problem.
Is this what it put us in a small class? So you could write this out every time you saw something?
You want to move back to the
No,
back
I
away
don't.
some.
No, because cheat.
No, don't. I'm telling you. I'm going to move you right now. I'm not going to mess with you. It's not in my nature to sit and argue with teenagers. They tell us on 28 RS, so from here to here is 7A. What else they tell us? I keep looking back at my book. What's the next thing they tell us? ST is 12A. The whole thing is. What is it?
RSTN. This is RS 28.
Oh, so they just tell us this. They didn't tell us the whole thing this time. They tell us this. They tried to trick you. So they didn't tell us the whole thing, so we can't say this plus this equals the whole thing. But they told you this twice. Well, what has to be true about those two expressions there? They have to be the same, right? If RS is 28 and RS is also 7A, they have to be equal to each other. So the equation you set up is 28 equals 7A. And what you did was you just divided by 7 there, right? So what's A have to equal? Now they asked you to find the variable, so we did that. What else did they ask us to find? ST, the length of segment ST. Well, how are we going to go back and find segment ST once we know what A is? If you're finding a variable, why would you ever want to find a variable? To and then figure out stuff, right? Now in algebra, a lot of what you did was you just solve the equation. Well, it doesn't do any good to just solve an equation. What's going to do you good is knowing what that variable is. Well, we now know that A is 4. So right here in place of A, what can we stick in? 4. And that's going to tell us how long ST is. How long is ST? What's 12 times 4?
48.
48. Could we also go back and figure out how long the whole thing is now? We know that this part's 28, this part's 48. Could you now figure out how long the whole segment has to be? Yeah, just add those two together. Pick me another one.
I did do 43 before.
Hold on to that one, I'll do it here in a minute. Problem 20. Find the precision measure and explain its meaning. So it says 3.75 meters. Remember, to find the precision number, take one of the very smallest units, and then you multiply that by 0.5 or a half. When you're dealing with decimals like this, you're going to go way out here and you're going to take one of the very smallest units, not 5, not 75, just 0.01 times by 0.5. Somebody help me out. What's 0.01 times 0.5? Close. So work it out there on the paper. Instead of wasting my scrap paper writing little notes. Yeah, 0.05 times 0.01, sorry, times 0.5. What's 5 times 1? 5. How many places you got behind the decimal?
2.
And then total of 3, so you got to move it over 3 places. That's your precision number. That's how precise the instrument that you were using, or whoever was using when they measured that, that's how precise they can actually get. And when they say explain it, all they mean to do is, that tells us that we're not sure that the exact measurement is 3.75, but we're sure that Christian could actually measure it within this amount, high or low. So you take this number, you subtract it off of that. So we take 3.75 minus that, and you get 3.745. And then you also take that same number and you add it onto it. So it goes up to 3.755. So we're saying we're not exactly sure that the measurement is completely correct, but we're sure that it falls between that range somewhere. Don't make precision harder than it is. You take smallest unit. This one's sort of hard because you got to remember that your 1/100th is your smallest unit. You take one of those, times it by 0.5 or a half, depending on what system you're dealing with. Then you subtract it to get how low it could be, add it to get how high it could be. That's all you do. Next question. Say it again. 42. What do they say? Eraser somewhere?
No.
Can't read them, are they? What's that? What's that one say?
It says erase all on the slide.
Can't read it up here, it's too close. You said 42, Christian? Problem 42. You just want to make me read a big long paragraph, didn't you? You know how good my reading is. Martin makes pewter figurines and wants to know how much molten pewter he needs for each mold. He knows that when a solid object with a volume of 1 cubic centimeter submerged in water, the water level rises 1 milliliter. Martin pours 200 milliliters of water in a measuring cup, completely submerges a figurine in it, and watches the water rise to 343 milliliters. What is the maximum amount of molten pewter in cubic centimeters Martin will need to make a figurine? So Martin's got this jug here, and he puts in 200 milliliters of water. And this is part of the reason that the metric system is better than our system. This is actually what the metric system is based off of. Our system, feet, inches, miles, all that. Does anybody know why a foot is 12 inches? Me either. Doesn't make any sense, right? Why make it 12? Why not make it something easier? Why is a mile, anybody know what a mile is? How many feet's in a mile? I do know. Do you know?
No. Teach it to me.
So,
1,000 is like
more than that. Flip to the back of your book. On that back cover back there. Should say 1 mile somewhere equals
So mine is worked out, or not worked out, but you can see it. Like it's darker and feet.
yeah.
Here, 5,000. I can't see that.
So write it in there. Just write feet in there. Is all it's missing. FT.
I can't see
You got 1 mile equals 5,280 feet. So 1 mile is 5,280 feet. Does that make any sense? Why 1 mile is 5,280? No, it means absolutely nothing. Metric system doesn't go off of that. He puts his little figurine in here, whatever it is he's making. His water goes up to 343 milliliters. What happened to the water? It went up because you stick something in it, run a bath for yourself, and you get in the bath, what happens to the water level? It goes up. All right? So, how much did it go up? 143 milliliters. 143 milliliters. It said, let's see, 1 cubic centimeter is submerged in water. The water level rises 1 milliliter. So for every 1 cubic centimeter, that equals 1 milliliter. Well, this is a pretty easy conversion here. If it went up 143 milliliters, how many cubic centimeters is it going to be? 143. So his pewter statue, whatever figurine that he's using, it's going to take 143 cubic centimeters of pewter. Each one's going to take that much. We'll do stuff like this later on in the year. And instead of just being 1-to-1 like that, we'll set up, if I remember what something like this is called.
Oh, good. It's not smaller.
How do you do it? Cross multiply and do all that stuff, right? We could have done the same thing here. We could have said, all right, 1 cubic centimeter compares to 1 milliliter. Well, we have 143 milliliters. So how many cubic centimeters is that? But wasn't no real reason to, because what's 1 times 143? And then you divide by 1, you get 143. So it wasn't any real reason to set it up that way. Other questions? Let her ask now, see if you didn't understand all those, because we're gonna
I'll
be
let
doing
him
it.
out. I didn't even have a word number on the board.
40? Yeah, don't worry about that one.
Go ahead.
Jason, you're not gonna ask him?
Oh,
36? Says use the figures to determine whether each pair of segments is congruent. What's it mean for two segments to be congruent? Have the same measure, all right? So they have the same measure. You did say 36, right? And something I should have said the other day, I'm hoping that you picked up on it. They give us this. When you see these little tick marks on two segments like that, guess what that tells you? They're congruent, they're the same. All right, so anytime you see something like that, that means those are congruent. Sometimes they'll put two tick marks so you don't get them confused with something else that's got one tick mark on it. And this one NP and LM. So is this top congruent to this bottom? No. The two sides are congruent, but the top's not congruent to the bottom because they're two different measures. The other thing, when we start dealing with angles here in a few days, if they wanted to show you two angles were congruent, they use these little arcs. So that tells us this angle is the same as that angle, or same measure as that angle. If they wanted to show us that these two angles were congruent, they wouldn't just use one arc again, because then that makes it look like all of these angles are the same. They would use maybe two arcs. Or they might use an arc with a slash to it, or an arc with a little circle on it, or anything that matches up that has the same markings in it tells you that those things are congruent. So if you got some shape and it's marked that way, that tells us these two segments are congruent, these two segments are congruent. That makes sense? It's just anything with the same mark means that they have the same measures. Maybe they wanted to tell you that this angle is congruent to this angle here is congruent to that one. They'd mark them that way. Other questions? Don't be afraid to ask. Make sure you understand it. Right, Christian? Everybody understands all those segment ones now. Because we're going to do those all year long. You got us. This plus this should equal the whole thing. Set up an equation, solve it. Then make sure you plug back in. All right, today is what is today? 26th. What we're going to cover today, should have covered this last year in algebra, at least part of it. Distance formula and midpoint formula. Go ahead and start copying this. Midpoint formula, maybe you covered in algebra, maybe not. See if I remember the distance formula from last year. I'll give you a little hint. I know Natalie remembers it.
A squared plus b squared equals c squared.
That's Pythagorean's theorem. That's one of them that you probably learned last year.
No, we haven't done it over. I should.
It looks like this. What's this symbol?
Root.
It's a square root, right? You're taking the square root of something, so you probably, it's going to be real helpful if you have that calculator that I told you about the other day. Get a calculator so you can do the square root, the formula. You were sort of close, because it does have the squares in it. All you do in the distance formula, subtract the x's, square that, plus subtract the y's, square that, add those two together, then take the square root. Don't write that down on next string, I'll have it on there. But that's the distance formula.
So they don't just change the signs.
Sometimes, it just depends. This is always a minus sign inside the parentheses. So if you are dealing with coordinates, this one could be a negative. And if it's a negative, then you got to switch that sign. So you got to be careful when you're dealing with it. Now, most of the math on this isn't real difficult, so it doesn't take a whole lot of doing, because when we're dealing with coordinates, we usually don't have a coordinate of like 6,250 minus 2,580. Usually our coordinates are like 4 minus 3, because we're on a coordinate plane, on a grid. All right, go ahead and write these down. All right, just basic ideas on most of these. The x coordinate on a coordinate system tells you to go how?
Right or left?
Left or right. Okay? So that tells you to move left or right. The y coordinate tells you to do what? Up or down. Very good. When you're on a coordinate system, if, mine's not very straight. If I draw a segment that goes from there to there, if it goes vertically, we really don't have to use the distance formula, because if it runs vertically or horizontally, all you got to do is count the little boxes. And that's going to give you, so on vertical and horizontal segments, make sure you remember this, on vertical and horizontal segments, just count. It's going to make your life a whole lot easier if you don't have to use that big long formula every time. So if it's a vertical segment or a horizontal segment, then you can just count to find the length. Yes. Yes. Sure. So you just count if it's vertical or horizontal. If it's vertical, if it's vertical, then you're going straight up and down. Your x's are always going to be the same. So you might just want to write in there, vertical segment, same, probably can't see that, can you? Same x's. If it's a vertical segment, you always have the same x's. Yeah. If it's vertical. always. The two x coordinates will be the same. So if it's, you might have 2 points like this. 5, 2, 8, -4. Your x's are the same. No, sorry. I was thinking 5, 8, and I wrote the wrong thing. The x's are the same. All you really got to do to find the length of this segment without graphing it is count from 2 to -4. So if you pick out that those x's are the same, then you don't have to use the distance formula. If it's a horizontal segment, then your y's are always the same. So it might be something like the 2 points on the graph are 3, -7, 7, -7. Since those y's are the same, we can just count the x's here. It's going to be a horizontal segment, and you just count from 3 to 7. How far is it from 3 to 7? 4. So the length of that segment, without even graphing it, is 4 units long. Now, the reason I put Pythagorean's theorem up here, and again, Pythagorean's theorem is a squared plus b squared equals c squared. We're not actually going to use it right now, but all Pythagorean's theorem is, when you have a diagonal segment going across through there and you can't just count to find the length of it, what somebody figured out a long time ago is you could draw in, it's like slope almost. You could draw in these two sides, and you can just count that one because it's horizontal. You could just count this one because it's vertical, and then you could use Pythagorean's theorem to find the length of the diagonal. So you could go through and use Pythagorean's theorem. As a matter of fact, I think on some of the homework tonight, it says use Pythagorean's theorem to find it. Listen carefully so you remember this. Do not use Pythagorean's theorem. Use the distance formula on everything that we do for homework tonight. But that's why I put Pythagorean's theorem up here, because it goes along with that. These are the two formulas. Go ahead and write them down. Please make sure. I remember last year when I was teaching this, a whole bunch of students, I don't know why, but wrote it down wrong. Had the pluses and the minuses in the wrong spot. And then they used that formula all year long, and it took me a while to figure out why they missed them every single time. Right on the distance formula, you got the square root, your x's, you're going to subtract them, square that number, plus, then you got your y's, you're going to subtract them, square that number. And it looks like a big, long, crazy formula. It's not near as hard as it seems, or as it looks, because these numbers are going to be pretty small. Sierra said something earlier, though. What you really, really got to be careful of is a lot of times you'll stick a negative in that second one. Well, then you got minus and negative, and you're going to have to change the sign to plus. Right, so you're going to have to change it to a plus. Now, be careful. Two negatives equal a positive when you're multiplying or dividing, or when they come right next to each other in a mathematical statement. But if this one's a negative and this one's a negative, that doesn't always mean that it's going to come out to be a positive. And we'll do a couple. The midpoint formula. This is probably the easiest formula we'll cover all year, but it's the one that people seem to have the most trouble with. To find the middle point, all you have to do is take your x coordinates, add them, divide it by 2. Just like if you were trying to find your average in a class for 2 grades, then you would add those 2 grades together and divide by 2. That's all you're going to do to find the midpoint. Add the x's together, divide by 2. Add the y's together, divide by 2. So don't make that harder than it is. Let me give you a second to write those down. System here, and I'm just going to do a couple real quick. If I can draw anything. My pen not working. That's our x. That's our y. We have a point here, point here. All we got to do to find the length of that segment, count. 1, 2, 3, 4, 5. Because it was a vertical segment. If we want to find the midpoint, you can just, if you're 5 spaces up there, your midpoint's going to be halfway, so your midpoint's going to fall right in there somewhere. And you just find the coordinates of that midpoint. 1, 2, 3, 4. Up. 1, 2, 3, 4 and a half. So if it's vertical or horizontal, it's pretty simple. All you got to do is count. You don't have to do anything else. It's when you start getting into diagonal segments that you have to use the formulas on to find them. Now I know Christian will say, why can't we just count? Well, you can't count the boxes when you're going across them diagonally because it doesn't work out. Right. See if you can set up that distance formula. Take a minute, try to set it up. Find the distance between those two. Every time I set up the distance formula, I write this out first. With all the x's and y's gone, just write it out with the minuses inside the parentheses, little squares up there, and the plus. Christian, what's our x coordinates there on these 2 points? So that's one x, that's the other x, so -4, 3. Kaylee, what's the y coordinates in? Now, look at what Kaylee did. Christian took this one first, then this one second. Kaylee switched them around. If you were doing slope formula, that would matter. You can't do that. If you're doing the distance formula, it doesn't make any difference. It's still going to give you the same answer. All right, so it doesn't matter if you swap them. Now, with what Kaylee did over here, this is what Sierra was saying a second ago. We got minus and negative. What's going to happen there to that sign? It's going to become positive. So let's see here. Change my color again. So that's going to make this a positive. Then you just do the math. What's -4 minus 3? -7. Plus, what's 1 plus 1? 2. So you're switching it around, right? So watch what happens if I do that. So if we put the 3 first, minus a -4. You're saying do it that way, right? Take the second one, then the first one. And then same way as what we did there. Change that. What's 3 plus 4? 7. Change those. Get 2. Again, with the slope formula, that matters. So it'd be a -2? Right. Now watch what happens when we do, let's finish it out this way. What's -7 squared? Be careful. What's -7 times -7?
49.
Positive 49. What's 2 times 2? 49 plus 4? 53.
7.2.
All right, if you have your calculator, this isn't going to come out even. 7.2, you said?
Yeah.
Something around there. Everybody knows this means approximately. When you round something off, use the wave equal sign instead of the regular equal sign. So you get 7.2 there. Now let's do it out this way over here. What's 7 squared? 7 times 7. What's negative 2 times negative 2? Positive 4. 49 plus 4. Is it going to come out to be the same thing? So it doesn't matter which order they go in for the distance formula. With slope formulas, that made a difference. Distance formula, it doesn't. Put your x's here, y's here. The order's not going to make any difference. Another thing that you might want to write down in your notes using this, since we're using the distance formula, 53 is not a perfect square number. It's not going to come out even. Sierra used her calculator to figure out what the square root of 53 was. I probably, if you leave your answer that way, just the square root of 53, that's an acceptable answer. So even if you don't have a calculator, you can leave it that way. Now there's some numbers, like let's say the square root of 8. 8's not a perfect square number. It's not going to come out even. But last year, Natalie, you learned that that can be broken down, right? Try to break it down into a number that has a perfect square, which is 4 times the square root of 2. 4 times 2 gives you 8. Well, what is the square root of 4? 2. So that answer is 2 radical 2. Did you guys do that in algebra last year? Breaking down radicals? Didn't? So we'll have to do some of it. So radicals are like fractions. You can't leave it if it's not reduced down. So you might be better off to grab your calculator and take the square root of 8 and change it to a decimal form. What I will write up here, list of perfect square numbers. You might want to jot these down. Give me the lowest perfect square number. 4. Then what? Remember, you multiply. 2 times 2 is 4. Then what? 3 times 3 is 9. 4 times 4 is 16. 5 times 5. 6 times 6. 7 times 7. 8 times 8. 64. 9 times 9. 10 times 10. 11 times 11. 21. 12 times 12. 144. These are all numbers that you get them down here. Are you going to need a calculator? No. If you get 144 underneath there, then you know that the square root of 144 is 12. And you can just write down your answer. 13 times 13, anybody know what that is? You start getting higher than 12 times 12, then you might want to grab your calculator, right? Because you might not know all your multiplication facts up higher than that. All right, find the coordinates of the midpoint. Try that one. This time you're using the midpoint formula. So write it down and try to get it plugged into the midpoint formula instead of the distance formula. Remember, with the midpoint formula, you're going to have two answers. You're going to have an x answer and a y answer because your answer is going to be a point, not just a number. It's going to be two separate coordinates. So this is the midpoint formula. And notice that a lot of times I don't write the subscripts, the little 1s and 2s in there, because for distance formula and midpoint formula, they really don't matter, as long as, Taylor, you remember that those two x's are the two different x's, right? That's all that matters. So just to make things shorter and easier, midpoint formula looks like that. You add the x's divided by 2, that's half your answer. Add the y's divided by 2. Sarah, what's my x's this time? No, I mean, what's, sorry, what are the x coordinates to start with? You're like 6 steps ahead of it. X coordinates. So it's 8 plus a negative 14. We're going to divide that by 2. Kaylee, what's the y coordinates? Now again, Kaylee switched them around to what Sierra told us, right? Does that matter? It's not going to make any difference in this. With the slope formula, that would matter. With distance and midpoint formula, it doesn't make any difference. Somebody help me out. What is 8 plus a negative 14? I'm going to move up here so I don't have to. Negative 6, good. What's 12 plus a negative 6? Positive 6. Then all you do is divide each one by 2. What's negative 6 divided by 2? Negative 3. What's positive 6 divided by 2? That's your midpoint. So if we actually drew this segment, if I came up here and made our little grid, and we went 8, negative 6, somewhere down in here, and then negative 14, be way over here somewhere, 12, somewhere way up in here, and we connected those, our midpoint should be about negative 3, 3. Looks like my line's way off, but the midpoint looks like it should fall somewhere there. My graphing's not very good. So with midpoint, you're getting 2 separate points. 2 separate coordinates, not 2 separate points, I should have said that. 2 separate coordinates, an x coordinate, a y coordinate. With distance formula, you're getting just one number. All right, see how smart you are. Write this one down, a little tougher. Christian can do all that stuff that we've done up to this point. That's all easy stuff. This one's a little harder. It says find the coordinates of point D if E is negative 6, 4 and is the midpoint of segment DF, and F has the coordinates of negative 5, 3. So they're telling you the midpoint. Instead of you finding the midpoint, they're telling you the midpoint. We know that F is negative 5, negative 3, somewhere about here. That's point F. D is negative 6, 4, somewhere about here. And our segment runs something like that. And we're trying to find the coordinates of point D up here. So they actually told you the midpoint this time, and you're trying to find one of the endpoints. Now, a lot of you can probably do it in your head, but what you're actually, when you're finding the midpoint, and I didn't write the whole formula down, you got x plus x divided by 2 y plus y divided by 2. And the whole formula actually needs something else out here. And this is going to be x of the midpoint, y of the midpoint. So that's the whole formula. But usually we just use this half of the formula because we're usually looking for the midpoint. Well, this time they tell us one of the x's is -5, one of the y's is -3, but we don't know the other y and we don't know the other x. And they also tell us that the coordinates of the midpoint is -6, 4. How can we go through and find this x right here? Any ideas?
Let's use them like last
You can do this right here. All of this, -5 plus something divided by 2, should end up equaling what? The -6, right? So what you're sort of going to do is just split this apart. -5 plus x divided by 2 equals -6. And then we're going to solve that. And you're right, you can like cross multiply, and I'm going to show you that here in a second. How would I find the y? What's the equation I can set up to find the y? What should this whole thing right here equal? Should equal 4. So if we solve those two equations, then we can find our x and y of this point D up here.